Hello, everyone. Welcome to this course on data visualization and business intelligence with Python. Well, data visualization and business intelligence are two of the most commonly used data analytics techniques to make data more understandable. Well, one of the mathematicians, Clave-Humby, he said that data is the new oil. What does it mean? It means that data or oil in its raw form needs a lot of transformation, cleaning, and processing. And once it becomes usable, we can use data to identify trends, patterns, and relationships. And those trends, patterns, and relationships help businesses and organizations make better strategic business decisions, which increase productivity for everyone, for all the stakeholders. And data visualization and business intelligence play an important role in that scenario. Well, this is a detailed course, a most comprehensive course on data visualization or business intelligence. So let's dive in. So, something about my background, my name is Mohammad Adil Sultan Khan. I work as a data scientist here in Silicon Valley and have been in my current role for over 5 years. I have pursued and completed MS Information Systems in Data Science Analytics from Santa Clara University here in California. I also have done MBA in Data Science and Finance from San Jose State University in California. And I also have an undergraduate degree in computer science and another master's in management information systems from Institute of Business Administration. All right. So the agenda of this course is that in segment 1 I will discuss the data visualization foundations, like things like what is data visualization, explore the conceptual and technical fundamentals of data visualization. Why is data visualization important? What are the advantages and disadvantages of data visualization? Why is data visualization important for big data, especially? What are the different types of visualizations? And when to use which one? How to create persuasive data visualization for audiences? And what is the claim-warrant framework in creating effective visualizations so that the visualizations that you create, they are specifically pursued for the audiences for whom you are creating them. And it's important to identify their needs, their desires and wants, and accordingly tailor your visualizations as per their requirements. In segment 2, I will do introduction to business intelligence. So I will cover topics like what is business intelligence, how business intelligence work, different types of BI methods, how BI data analytics or business analytics work together, and traditional business intelligence versus modern business intelligence. What are the benefits of business intelligence? The categories of BI analysis, predictive, descriptive, and prescriptive analytics. I will also explore some of the BI dashboards and why are they so important. I will also discuss popular BI tools, and in the end, I will also discuss the data wrangling importance using Python. In segment 3, I will cover data visualization and business intelligence in action using some real time projects. Uh, my first project that I will discuss is a LinkedIn top skills data set. So I will use data visualization to show which skills are highly ranked or which are in high demand, and the visualization will show that. Then my second project that I will discuss will be Australia's gender pay gap to show you that uh, it's a uh, one like a identification from the data that males are paid more in Australia than females, and uh, I will include some external data to counter that claim. Uh, so that will be that, and in the third, I will use a cryptocurrencies data set, and my claim there would be: should you be tempted to invest in cryptocurrencies? I will use data visualization to support the claim. And in the end, I will give a demo of data wrangling and creation of data visualization, like a preparation of the data set before we create the final visualization in a Python Jupyter notebook. And I will reiterate the fact that how important data wrangling or data cleaning part is before creating any visualization. All right. So what is data visualization? Well, data visualization is a graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to find trends, outliers, and patterns in data. Visualizations help to present data to non technical audiences without confusion, for sure, if they are created in the right manner. Uh, in the world of big data, data visualization tools and technologies are essential to analyze massive amounts of information and make data driven decisions. Why data visualization is so important these days, especially with the rise of big data and as more and more data is being collected, data visualization is becoming more and more important. But why? Because data visualization helps people to see and understand data better. And effective visualization brings people on same page regardless of their expertise. For example, if some of the team members they have different opinions about some subject matter, so by creating an effective visualization from data will bring all of them on the same page, because nobody can deny the facts or deny the trends that the visualization propose, and eventually they will agree what the visualization show you. So every field these days, government, finance, marketing, mm, healthcare, consumer goods, sports, they are all benefiting from making data more understandable. Data science skills are in high demand, and having good data visual skills is imperative. Well, traditional education draws a distinct line between creative storytelling and technical analysis. However, the modern professional world also values those who can cross between the two. The data visualization sits right in the middle of analysis and visual storytelling. Well, what are the advantages of data visualization? Well, data collection rate is increasing exponentially, and visualizations help in understanding the data better. This, uh, that's why this is so important. Some advantages of data visualization include it helps you to show trends, patterns, and outliers. It displays complex relationships. It the color that you use in your visualization, the color patterns differentiates between important attributes. Uh, it can help you to share information data easily with the intended audiences. It enables teams to take appropriate actions or strategic decisions. And it can also help you to unlock key values for strategic decision making in business. Well, there are also some disadvantages of data visualization if it's not done in the right manner. When viewing a visualization with many different data points, it's easy to make an inaccurate assumption, or sometimes the visualization is just designed wrong, so that it is biased or confusing. Well, for example, a pie chart cannot be used in all situations. It can only be used in situations where you have categories, and for each category you are showing some percentages. However, if you use pie chart beyond that point, it will be wrong to use that. So every visualization can be used only in certain situations. And if you use a wrong visualization, then the the message that it conveys will be wrong as well. So that's why it's so important to make sure that you use the right one. Uh, and some disadvantages include if it is designed wrong, it can uh, project biased or inaccurate information, and the correlation it shows between two variables, for example, they may not mean actual causation. Like one does not cause another thing to happen if there is correlation. Core messages can get lost in translation, and data wrangling, especially if it is not done properly, it could lead to inaccuracies and wrong assumptions. Well, the history of data visualization has been around us since early 18th century, and the guy called Charles Joseph Menard, he's known as the pioneer of data visualization. He was a French civil engineer recognized for his significant contribution in the field of information graphics, in civil engineering and statistics. Menard was, among other things, noted for his representation of numeric data on a geographical map, especially his flow maps. Menard's first statistical graph from 1825 depicts several time series related to Paris pavement maintenance over the preceding 2 centuries. However, Charles Menard's map of Napoleon's disastrous Russian campaign of 1812 has been one of the best visualizations ever created. This graph is notable for its representation in 2 dimensions of 6 types of data: the number of Napoleon troops, the distance, the temperature, the latitude and longitude, the direction of travel, and location relative to specific dates about the famous Napoleon's Russian campaign in back in 1812. And one of the statisticians, professor called Edward Tufte, he described that graph as may well be the best statistical graph ever drawn. Well, this is the one I was talking about. Uh, you can see early 18th century, and uh, this type of visualization was created at that time as well. So it shows you the map of Napoleon's disastrous Russian campaign, uh, and the variables on the chart. It shows the number of Napoleon troops, distance, temperature, latitude, and longitude, the direction of travel. So let's see the newer version of this. Well, the chart is the same, but it's been recreated in English uh, as well as French. So the color here, there are two colors, the tan color and the black color. The tan represents the man who invaded Russia itself, while the black represents the retreat from Moscow. And the widths of those color zones shows you the basically shows you how the number of soldiers who are marching, they were lost in the course of 6 month campaign. So as the width of these tan and black lines becomes smaller, it indicates that so many soldiers uh, lost their lives during the campaign, um, because of the attacks or of the diseases or the cold or the starvation. So this is one of the most remarkable visualizations created in early 18th century, and this is one of the modern redrawing of Charles Joseph Menard's figurative map of 1812 French invasion of Russia. It shows you the conversion in Fahrenheit and Celsius as well for the temperature. So it shows you as they were marching how the temperature was moving, because of the winter at that time. All right, so why data visualization? Well, data visualization can be utilized for a variety of purposes, and it's not only reserved for use by data teams. Management also leverages it to convey organizational structure and hierarchy, while data analysts and data scientists use it to discover and explain patterns and trends. In fact, Harvard Business Review categorizes data visualization into 4 key purposes: idea generation, idea illustration, visual discovery, and everyday data visualization. Well, why data visualization? The idea generation part. It's so important because data visualization is used to generate ideas in teams using identified trends, patterns, and relationships from the visualizations, and and it brings the the teams and the whole organization on the same page. Uh, Data visualizations are used in discussion and brainstorming sessions by supporting different perspectives and highlighting the common concerns or viewpoints. Data visualizations align teams and whole company on common goals and strategic objectives by magnifying the real scenarios in easy to understand terms. Uh, why idea illustration is important? Because data visualization for idea illustration assists in conveying an idea, such as a tactic or process. It is commonly used in learning settings such as tutorials, uh, certification courses, centers of excellence, but it can also be used to represent organizational structures or processes, facilitating communication between the right individuals for specific tasks. Project managers they frequently use Gantt charts or waterfall charts to illustrate workflows. And data modeling also uses abstraction to represent data flow within an enterprise information system that helps them to make it easier for developers and business uh, analysts as well as data architects to understand the data better. Why visual discovery is important in data visualization? Because it helps everyday data visualization uh, to, to become more aligned with the data teams. Uh, Visual discovery helps data analysts and data scientists and other data professionals to identify patterns and trends within a data set. And everyday data visualization supports the subsequent storytelling after a new insight has been found. For example, if the data team found a new insight in the data, they can build a visualization and bring the whole team on board and then give the demo of that visualization through some storytelling and propose a new finding which unites everybody. What is data visualization good for? Well, visualizations are tools that can make complex concepts easier for humans to understand. In the words of engineer and inventor Douglas Engelbart, a tool does not just make something easier, it allows for new, previously impossible ways of thinking, of living, and of being. The utility of data visualization can be divided into three main goals: to explore, to monitor, and to explain. While some visualizations can span more than one of these, most focus on a single goal. Let's see how they are important. Uh, what is data visualization good for? As far as to explore uh, is concerned, so when users are looking for an open-ended tool that helps them to find patterns and insights in data, a data visualization focused on exploration and fast iteration can help. Exploration tools should have strong connections to other tools that collect, extract, clean, transform, and curate load data. To monitor, well, when users need to check on performance, a data visualization focusing on monitoring is best. Like there are several visualizations that that help teams to identify performance versus some benchmarks or some key performance indicators. So that's where uh, it can be used. Monitoring tools such as dashboards, they should focus on leading indicators and showing information that is connected to useful and direct actions. Well, leading indicators they predict future performance and they help drive your daily initiatives, while lagging indicators they reflect past performance to assess success and shape long-term strategy. And we can use both of them in visualizations or dashboards using the components or using the data that identify either the leading or the lagging indicators. To explain, when users want to go beyond the what of a problem and dig into the why, a data visualization focused on explanation is ideal. Like there are several hypotheses or questions uh, that often teams ask about data, uh, and making an effective visualization can help prove or reject lots of hypotheses or claims. Explanatory visualizations are often handcrafted to help a broad audience understand a complex subject and usually are not able to be automated. So, why use data visualization? Well, according to IBM, 2.5 quintillion bytes of data are created every day. And the research scientist Andrew McAfee and Professor Eric Brynjolfsson of MIT, they pointed out that more data cross the internet every second than the amount of data stored in the entire internet just 20 years ago. So now imagine the amount of data, the rate of data being collected or being processed every second is increasing at such a rapid pace. As the world becomes more connected with increasing number of electronic devices, volume of data will continue to grow exponentially, and IDC predicts that there will be 175 zettabytes of data by 2025. And with so much data, uh, more opportunity like the amount of opportunity or will increase also rapidly to make the data more understandable and to in order to process that data or to identify trends, patterns, and relationships in that data, effective data visualizations will definitely become more and more important. Well, raw data is hard for human brain to comprehend. It's difficult for human brain to comprehend large numbers of like numbers of larger than 5 without drawing some kinds of analogy or abstraction. Imagine a 10 million row data set. I mean, nobody can look at those numbers and find uh, insights. So, uh, data visualization will definitely help. Big data is useless without understanding. That's why data visualization plays an important role in everything from economics to science and technology to healthcare and to human services. By turning raw data into graphs, content becomes easier to understand and use. So that's why data visualization is used more and more as the amount of data collected is increasing. Well, what are some of the data visualization principles? Well, the number one principle is to have a clear purpose. Before creating a data visualization, defining a clear purpose will make the process easier and useful and prevent wasting time creating visuals that are not required. Data visualizations help in strategic decision making and providing answers to hypotheses. It can be used to track performance, monitor customer behavior, and measure effectiveness of processes. Another principle is a very important one is to know your audience. Because without knowing the audience, we cannot make effective visualization. We need to know their demands, their needs, their wants, and desires. Identifying audience before creating database is absolute must, as it should be compatible with audience expertise and help viewers to view and process data easily and quickly. Well, audience preferences guide every decision about visualization. Things like formatting, color, uh, intensity of color, they, they are they're very important, and different audiences have different tastes about them. So it's really important to identify and to understand the intellectual level of your audiences. Know the audience. Continue from the last slide. We should identify what information audience already has and what additional information can our charts provide, focusing mostly on that missing information to include in the charts. Some chart types are not suitable for a certain group of audience, so it's important to match charts with audience needs, requirements, and expertise. So before designing a data visualization, we must answer the following. Who will be using that data? What are their objectives? How will they interact with the data? What business questions do users need answered? Another very important principle is to keep it simple. Don't overcomplicate things, or don't make your chart too complex. Just keep it simple. Simplicity allows us to visually drive conclusions from data more easily. Ineffective visualizations such as lengthy tables or complex charts require more conscious thought to analyze information, slowing viewers down and reducing impact. To quote Stephen Few, one of the founders of modern data visualization, he said, "A picture is worth 1,000 words, but only when the story is best told graphically rather than verbally, and the picture is well designed." Another very important principle is to use colors wisely. Well, color is a great way to focus your viewers' attention, and it is best not to overwhelm people with too much of it. When using color in data visualization, you need to think about hue. A hue meaning what color something is, like which color to use. And intensity, like each color has different intensity or different shade, uh, especially if you're familiar with the Plotly library in Python. There are lots of shades of each color, or like with different intensity. So we need to use the right hue and right intensity of each color. We should also keep use of color consistent. Like if we are showing multiple charts, or in the dashboard we have multiple charts, we need to make sure that each color is being used consistently. For example, if a red color is used to indicate a higher temperature, while green is used to indicate a lower temperature, then we need to make sure in the other chart as well we are using the right sequence or the right selection to make things uniform. Another very important principle is to use the right chart type. Well, the primary purpose of data visualization is to help viewers discover actionable insights. When selecting a chart type, you need to ask yourself what story you are trying to tell, who your data visualization is for, and what are their priorities, what problem you are trying to solve, what type of data you have. For instance, do you have categories of data? If so, how many categories are there? You need to know all these things. Using the right chart types. Well, pie charts are best for comparison between a relatively low number of categories. Bar charts are best for precise comparisons between categories, and like when you want to show negative and positive values in the data set. Scatter charts, they are great to show correlation and clustering, especially if you have a lot of data. And line charts, they emphasize trends over time. Bubble charts showcase distribution or relationships in large data sets. Area charts let you compare volumes of data easily. Another very important visualization principle uh, is hierarchy. An important principle in data visualization dashboard design is definitely hierarchy. Uh, and what does it mean? It means that, uh, for example, there's an expected widget arrangement that user will understand intuitively without any extra explanation. The right hierarchy is what helps make visualized data in dashboards easily scannable. Hierarchy has few simple concepts. The most important information should be located at the top left corner of the dashboard, as this is a prime location and it is the first place that a viewer looks. Widgets that follow the top level should explain in more detail our top level key performance indicator. Text widget can be used to create titles that can help the content be more clear. White space is important. It is better to leave a gap rather than make something bigger just to fill space. And visual hierarchy is crucial in data visualization as it helps viewers quickly get the important information. And the right logical order and grouping of related items together can contribute to better visual hierarchy and to a better data visualization eventually. We also need to make sure that we are highlighting the important information uh, because data visualizations they tell a story. By highlighting the most crucial information first, viewers can see what the story is all about. You can also use the position of the data to create emphasis. For Western audiences, the top left is considered the prime real estate. Uh, for example, in just put one dashboard you are seeing in the bottom. Uh, it shows you total sales by month. Uh, it's likely the most important information for audience. Like they want to see total sales by month when they are identifying this data. And the live board below it shows that data in the top left part shows you sales by month because it's what uh, is more important for the audiences. Another very important principle is to avoid clutter. If you try to put too much information in the same visualization, the actionable information gets lost in the noise. Instead, it is better to encourage the viewer to discover information through progressive disclosure, revealing each piece of information as you go to build a complete picture. For instance, start by just showing the highest level of data in your presentation and progressively drill down into the data to answer questions from your audience. So, there are some categories of clutter that we need to be aware of. Uh, Frame, the background area of the chart. That's where you draw the chart. That's the whole frame. Uh, Graphical objects, the elements that are used to visualize or display the data values. Um, for example, if you're using dots or lines or stars to show your data points. Axes, the reference lines along the edges of the frame, for example, the x-axis and the y-axis, or in case of three-dimensional data, the z-axis, the third axis. Uh, Labels, all text elements that describe the chart's data values, access, etc. Uh, for example, when you hover on the chart, it shows you some information. So you need to make sure that you are using the right amount of text on the hover element or in the legend. Overlay objects, all elements that are overlaid or inserted into the chart for explanatory purpose. Data visualization approaches and examples. Well, with dozens of chart types available, each is known to suit one particular purpose or another. And it is extremely important to choose the right chart type. In fact, picking a wrong form is one of the most common and critical visualization mistakes. Let's look at 7 common examples of data visualization tasks and see what chart types are the best fits. In the next few slides, I will cover each of these scenarios and show you which chart type is more better suits that situation. The situations that I will cover in the next slides are comparing data, exploring composition and part-to-whole relationship in data, tracking data over time, analyzing data distribution, evaluating current performance of data, examine project data, and making sense of geographical data. So, for example, if you want to compare your data, the most commonly used chart type is a bar chart that is being shown in the middle of this slide. Uh, Bar chart or column chart, they are used for a straightforward comparison of quantitative values by category. We can also use stacked charts to add a look at the composition, or we can also use radar charts for a comparison of cyclic data. For example, you can use bar charts to visualize products by revenue and referral sources by user. Um, we can use radar charts to compare air temperature by a month, for example. And this is the example of radar charts and stack charts. Well, if you want to explore composition and part to whole relationships in the data, then we can use pie charts or donut charts for a basic look at the percentage composition of a value, or we can use pyramid charts to explore the composition of hierarchical data. We can also use tree map charts to look into complex hierarchical data, and we can also use funnel charts to measure stages of processes and discover bottlenecks. Uh, we can use pie or donut charts to visualize a breakdown of the overall sales by retail channel, for example. We can use tree map charts, for example, for web traffic by source. We can use funnel charts for things like sales funnels. And these are the examples of how they look like: the pyramid chart, the tree map chart, and the funnel chart. Now, designing them properly and the right manner is crucial. Well, in this situation, when we want to track data over time, the most frequently used chart is a line chart or the spline chart for a basic view revealing trends, peaks, and so on. We can also use area charts as another option for cumulative data, or stock charts for big data sets such as financial and stock market data. We can also use a very popular chart type in finance or in stock market data called Candlestick chart, which help you to add a look at the distribution of values within each period of time. Also, we can use sparkline charts for a quick representation of the big picture with no axis. Well, line, spline, or area charts we can use to visualize things like sales or web traffic over time. Stock charts we can use to identify stock price change or volatility in the stock market, uh, or the amount of liquidity in the market. Candlestick charts we can use to identify things like stock price with a look into value fluctuation ranges. Uh, like it uses a moving average and plus minus 2 or 3 standard deviation from that moving average, so to indicate the lower bound and the upper bound, so user can identify the fluctuations and the volatility or the moving average accordingly. um, yeah So this is how the area chart or the sparkline chart and candlestick chart looks like. The one on your at the top left is the area chart, one on the top right is a sparkline chart, and one in the bottom is a candlestick chart. So candlestick chart, as I explained, it shows you the stock market data, and each bar shows you the opening, the closing of each day or each time period that you are using in that data, each day or each week or any time period that you're using. And the lower part of each bar is also the lower and the high value went on that day. So if a high is if your closing is greater than your opening, then it will be a green chart, and otherwise it will be a green bar, or otherwise it will be a red bar. Well, if we want to analyze data distribution, we can use the following charts: dot charts or scatter charts to examine trends in distribution and correlation between two variables. We can also use bubble charts to consider three dimensions of data. We can use box or whisker plots uh, when we want to analyze data distribution, and they will help to look at main distribution ranges and median values. We can use error charts to inspect error distribution, or heat map charts for a colored matrix based view of multiple subcategories. We can use range charts uh, to find range between the maximum and minimum values. Or we can also use another popular chart type called polar charts for multivariate data with a spatial perspective. Box and whisker plots we can also use, and they help find information, things like destinations by flight delay, duration, or we can use scatter charts to visualize information, to visualize system interruptions by waiting time and by duration, or results of an experiment. So this is how the bubble chart, the error chart, and the range chart looks like. The one on your top left is a bubble chart, one on the top right is an error chart, and the one on the bottom is a range chart. Well, if you want to evaluate current performance data and compare the actual value against some benchmarks or key performance indicator values or qualitative ranges, and to visualize single value data as indicators, the following chart types are commonly helpful: circular gauges for a radial scale, or linear gauges for linear scale, or bullet charts for a more space efficient visualization on a linear scale. We can use circular gauges to visualize speed, like a speedometer or wind direction, linear gauges for air temperature thermometer or tank volume. Here we are seeing bullet charts, the linear gauges or circular gauges. The one on the top left is a bullet chart. So bullet chart here is showing actual and budget sales per product. Like each product, uh, how much was the actual and the budgeted sales. Uh, so they show a lot of information about that. Well, if you want to examine project data, we can use Gantt chart or resource chart. Gantt chart helps us to keep an eye on activities on a project schedule. They are commonly used by software development teams as well to record like uh, what task each person is working on, how much time is left, like the whole schedule, the timeline. Resource chart to review resource occupancy. For example, you can use Gantt charts to visualize project activities on a schedule or plan activities. Uh, the one on your top left is a Gantt chart, and the one on the top right is a resource chart. Well, if you want to make sense of geographical data, then we can use chart types like choropleth maps to identify differences across geographical areas. We can use dot maps to understand geographical distribution trends. We can use bubble maps to add a size variable into a visual, or we can use connector maps for a look at geographical connections. We can also use flow maps to explore how objects move between locations when direction is important. So one on your top left is a choropleth map that shows here, for example, unemployment rate by state in US in July 2012. So a darker color shows you uh, higher unemployment in percentage, and the lighter color is less unemployment in that state. One on the right side is a dot map, and uh, one on the bottom right side is a dot map, and one on your bottom left side is a flow map which shows direction. Well, some very commonly used types of charts and graphs. Let's discuss them. So the line chart is very popular. Line chart connects distinct data points through straight lines. It is used to find trends, patterns, and variable changes. When to use line charts? Well, this type of chart helps measure how different groups relate to each other. This type of chart is also effective for demonstrating progression, making them suitable for scenarios like project timelines, production cycles, or population growth. Well, best practices for line charts. Always ensure that the data you are representing in the line chart has a logical order. Or in other words, when you are doing the data wrangling part in Python or in R, make sure that you have sorted the data either in ascending or descending way. So that's how it will have a logical order. Also, make sure that you add context through annotations and labels, like put annotations on the chart. If the dataset is large, use transparency or spacing to improve visibility. Another very important and popular chart type is bar chart. Well, bar chart represents data using rectangular bars or columns, and the length of each bar corresponds proportionally to its value. You can present these bars horizontally or vertically. When to use bar charts? Well, bar charts are excellent for comparing the values of different categories or groups. They are also helpful in showing distribution of data across different categories. Best practices for bar charts. Well, clearly label each bar and axis with concise labels. Limit the number of bars in categories to avoid cognitive overload. Like, don't make lots of bars in one chart. Uh, make only as many as are needed. And purposely use colors to highlight key points and convey meaning so that the audience easily can see uh, important trends or important insights in the bar chart. Tree map charts, what are they? Well, tree maps are hierarchical charts that allow to visualize data as nested rectangles. These rectangles or branches convey the structure and distribution of data, making tree maps useful for visualizing categorical and hierarchical relationships. When to use tree map charts? Well, apart from visualizing hierarchical data, this type of visualization helps to illustrate part to whole relationships within a dataset, demonstrating how each category contributes to overall composition. Best practices for tree map charts? Well, always ensure that the size of rectangle is proportional to the size of the category being represented. Clearly label each rectangle with concise labels and use a single color with varying shades to show changes in data in the tree map chart. Another very popular chart type is a scatter plot. Well, scatter plot are types of visualizations that show a collection of data points scattered around the graph. The data points can be evenly or unevenly distributed. When to use scatter plots? Well, scatter plots are ideal for exploring relationships and patterns between two continuous variables. They can help you identify trends, correlations, uh, or potential clusters in the data. Best practices for scatter plots? Always highlight outliers if present in the graph to showcase data distribution. Add a trend line to highlight relationship between variables and consider using different colors or marker size for overlapping points. Heat map charts. What are they? Heat map charts are a type of map data visualizations that use a system of color coding to represent value. Uh, so they use different intensities of colors to highlight some important information. Uh, when to use heat map charts? Well, heat map chart is commonly used to establish relationships between two variables across a grid. The intensity of colors demonstrates the variables, making it easy to identify patterns and trends. Well, what are the best practices for heat map charts? Well, choose an intuitive color palette that effectively conveys the magnitude of values. Use visual cues to highlight significant values and utilize the design principle of white space to prevent overcrowding. Pareto charts. A Pareto chart combines a bar chart and a line graph. The rectangular bars correspond to individual values in descending order, while the line graph displays a cumulative percentage total, or it shows the trend in there. So, this type of chart follows the famous Pareto principle that emphasizes that 20% of causes result in 80% of problems. And when to use Pareto chart? Well, a Pareto chart effectively showcases key contributing factors to a particular outcome. Another use case of a Pareto chart is when you want to highlight problems based on their impact. What are the best practices for Pareto charts? Well, you may always make sure that you arrange all the categories in descending order based on their frequency, impact, or contribution, and use colors purposefully to enhance clarity. Geocharts. Geocharts are a type of data visualization that represent data on a map. They show spatial information such as the distribution of values across different regions, countries, or states. When to use geocharts? If you want to analyze geographic information in your data, you can use these types of charts to discover hidden patterns and trends. Each region, such as a country, state, or district, is shaded or colored based on the magnitude of the variable presented. What are the best practices for geocharts? Well, make sure that you select appropriate map projection that matches your region, and you use color shading to highlight particular regions. Make sure you label the projections to represent data points on the map. Alright, now we are entering the segment 2 of this course. What is business intelligence? Well, business intelligence combines business analytics, data mining, data visualization, data tools, and infrastructure, and best practices to help organizations make more data-driven decisions. In practice, you have got modern business intelligence when you have a comprehensive view of your organization's data and use that data to drive change, eliminate inefficiencies, and quickly adapt to market or supply changes. Business intelligence is an infrastructure that helps in the process of collecting, storing, and analyzing data from business operations. BI, its short form. BI focuses on descriptive analytics. BI provides comprehensive business metrics in near real time to support better decision making, and you can create performance benchmarks, spot market trends, increase compliance, and basically improve every dimension of your business with better business intelligence. Well, what are some types of analytics? There are three different types of analytics: descriptive analytics, predictive analytics, and prescriptive analytics. Descriptive analytics describes the past status of the domain of interest using a variety of tools through techniques such as reporting, data visualization, dashboards, and scorecards. Predictive analytics applies statistical and computational methods and models to data regarding past and current events to predict what might happen in the future. Prescriptive analytics uses results of predictive analytics along with optimization and simulation tools to recommend actions that will lead to a desired outcome. Now, the visualization on your right side shows you business intelligence. It covers descriptive and diagnostic analytics, like what happened and why did it happen. And the advanced analytics covers predictive analytics and prescriptive analytics, like what will happen and how can we make it happen. And the advanced analytics is where the machine learning and the deep learning and the new concept of artificial intelligence, uh, they will be uh, they come under this part, and especially the new technology like ChatGPT. It is also falling under advanced analytics. Well, what is business analytics and data analytics? A subset of business intelligence, business analytics refers to a process of using raw data to find trends and predict outcomes. Some common methodologies in business analytics are data mining, that helps in sorting through large amounts of data to identify trends and patterns. Aggregation, which helps in the process of gathering and organizing data prior to analysis. Forecasting helps in analyzing historical data uh, to estimate future outcomes. Predictive modeling, extracting information from data sets to identify patterns and trends. And data visualization helps creating visual representations of data analysis, such as charts, tables, or graphs. And business analytics focuses on predictive analytics, like what will happen. Um, Data analytics is a technical process of mining data, cleaning data, transforming data, and building the system to manage data. It takes large quantities of data to find trends and solve problems. It is used across disciplines from governments to science. How business intelligence works? Well, first of all, there are lots of components. BI or business intelligence has different components like data, which is a raw material. It has volume, velocity, and variety, and information or actionable data. Another component of BI is operational and transactional system. These are places where work is done and raw or the siloed data is generated. Data integration, which is the process of aggregating data from several sources and preparing data or cleaning data from multiple sources and then storing it in a warehouse to present a unified view uh, um, that's being used by BI tools and applications to analyze data. Data warehousing is the storing or staging of integrated information separate from operational systems in optimized form of analysis. And every organization these days, they have a data warehouse or a data lake or a database, depending on their requirements, where they store or stage or save all the data after data integration or after the ETL part. They store data in data warehouse. And then they run business intelligence on the data warehouse that uses tools and applications which help in analyzing information. Big data, it could mean really large, or it could mean unstructured data, or it could mean overly complex, or it could mean all of the above. Well, the three V's of data uh, are volume, velocity, and variety. Volume refers to the amount of data, um, and velocity refers to the rate, the sheer pace at which data is being generated and collected and stored. And variety refers to the number of types of data. So the visualization on your right shows the whole process from data integration, where it integrates and cleans data from multiple sources, to data warehousing, where it stores integrated data, to business intelligence, where it helps in presenting and analyzing information. And the whole process is a scenario where crude oil is being discovered, then it goes to oil refinery for cleaning, processing, and transformation, and it's ready to use afterwards. So data also follows the same process as the crude oil. That's why we say data is the new oil. How business intelligence works? Well, businesses and organizations have questions and goals. To answer these questions and track performance against these goals, they gather the necessary data, analyze it, and determine which actions to take to reach their goals. On the technical side, raw data is collected from business systems and data is processed and then stored in data warehouses, the cloud applications and files. And once it is stored, users can access the data, starting the analysis process to answer business questions. Well, business intelligence platforms also offer data visualization tools, which help in converting data into charts or graphs, as well as uh, to present data to all the stakeholder or decision maker. Like there are several platforms and tools that help us doing that. For example, Tableau or Power BI or Pentahau tool that helps in ETL process. They also help you to build data visualizations and charts and dashboards and graphs to present your information to your stakeholders. So the chart on the right side shows that process from the data creation part to information consumption part, like from several sources data is collected, and by the data integration process where it is cleaned and transformed and merged and joined and then it's stored in the data warehouse, which can have staging area or enterprise data warehouse or data marts or ODS, each of which is a separate area in data modeling. And eventually it goes to business intelligence where it is used for insight generation or analysis. Well, different types of BI methods. Business intelligence has evolved to include more processes and activities to help improve performance, and these processes include data mining that uses databases, statistics, or machine learning to uncover trends in large data sets. And it also includes reporting, where it's used to share data analysis with the stakeholders so they can draw conclusions and make decisions. Also includes performance metrics and benchmarking, where it helps in comparing current performance data to historical data to track performance against goals, typically using customized dashboards. Also, for descriptive analytics, using preliminary data analysis to find out what happened. For querying, asking the data specific questions, like BI pulling answers from datasets. Or for used for statistical analysis, where it helps in things like taking the result from descriptive analytics and further exploring the data using statistics, such as how this trend happened and why it happened. These processes also include data visualization, which is, as discussed earlier, turning data analysis into visual representation such as charts and graphs and histograms to more easily consume data for the audiences. Visual analysis, which is exploring data through visual storytelling to communicate insights. Data preparation, while compiling multiple data sources, identifying the dimensions, and measuring that helps in data analysis. How BI, data analytics, and business analytics work together? Well, business intelligence includes data analytics and business analytics and uses them as parts of the whole process. Business intelligence helps users draw conclusions from data analysis. Data scientists dig into specifics of data using advanced statistics and predictive analytics to discover patterns and forecast future patterns. Business analytics also includes data mining, predictive analytics, applied analytics, and statistics. In short, organizations conduct business analytics as part of their larger business intelligence strategy. So the visual on your right shows you from business intelligence back to from data warehousing to data integration and from the sources of data. The same type of chart we saw earlier, but with a different perspective. Like the sources of data are the systems of record, and data integration and data warehouse are two areas of systems of integration, and systems of analytics is the business intelligence part. So that's how BI and data analytics and business analytics they work together. Well, traditional BI versus modern BI. Modern BI platforms provide continuous pulse monitoring of the organization through rapid analytics and empower businesses to accomplish mission objectives through predictive analytics. Modern BI prioritizes self service analytics and speed to insight, while traditional BI used a top down approach where BI was managed by IT. So, in modern BI, basically anybody can in the organization can use the data and generate insights through the tools and self-service applications. They don't need the skill to uh, make visualizations or convert data into graphs. The tools will help them do that. However, in the traditional BI, this was only done by the skilled or the technical uh, people like the IT team. Now, with the rapid proliferation of data analytics tools, most teams now utilize those tools to do their data analysis. What are the benefits of business intelligence? Well, great business intelligence helps businesses and organizations ask and answer questions of their data. BI is more than just a software now. It's a way to keep a holistic and real-time view of all your relevant business data. Implementing BI offers a myriad of benefits, from better analysis to an increase in competitive advantage. That's how it's so important for organizations these days. And some of the top business intelligence benefits include it help in data clarity, increasing efficiency. It helps organizations to provide better customer experience, providing or improving employee satisfaction, reducing complexity in the tasks, and it helps in finding the trends, insights, patterns, and relationships in the data. It also enables improved data access at lower costs, and at the right time, the right data is available for everybody. These are some of the benefits of business intelligence. Well, what's a BI dashboard? Well, a BI dashboard are information management and data visualization solutions to analyze data. Content creators can use interactive elements like filters and actions to combine charts, graphs, and reports in a single screen for snapshot overviews. So that's what dashboard is. You can put lots of charts and lots of figures in the same uh, frame or in the same page, and then connect them together or make some story out of it so that user can understand lot of information in one go or in one chart uh, about the data. Dashboards are one of the most popular capabilities of BI platforms because they present easily understandable data analysis, allow you to customize which information you want to view, and provide a way to share the results of your analysis with others. Well, dashboards and reports are critical for business intelligence, and dashboards can help users understand complex reports. Dashboards are ideal for stakeholders who need at a glance overviews of performance. Uh, Reports are for stakeholders who need more details and who want to slice and dice data to uncover insights. Well, there's a very useful model that helps in making better visualizations, which is called a Claim-Data-Warrant model for analyzing argument. Before creating any visualization, you need to have some claim backed by the data that you used and backed by some warrants. So it's a whole framework which is very important in making better data visualizations. So a claim is something the author wants the audience to believe. And data is the evidence or the appeal they use to convince the reader to believe the claim. Data is like the data set that you use to prepare the visualization. And claim is something that you want the audience to believe through the visualization that you create. And the warrant is an implicit assumption that links the data with the claim. Stephen Dolmin identifies three essential parts of any argument as the claim, the data, also called grounds or evidence, which support the claim, and the warrant. The warrant is an assumption on which the claim and the evidence depend. Warrants explain why the data support the claim. For example, claim is that you should buy our toothpaste whitening product, and data shows that teeth are 50% whiter after using the product for a specified time. And the warrant is that people want whiter teeth. So that's how it is. And there are some qualifiers and rebuttals for claim and data, and warrant supports that based on some backing. Alright, so this is one of the projects that I wanted to show you so that you can have an idea about data visualization in real scenario. It's a LinkedIn top skills data set, and the top objective of this project is to redesign a data visualization, a visualization that existed somewhere uh, in a newspaper or a project report or sales report. And this will help you to learn from others, or to sharpen the critical perspective on data visualization, or reason about design decisions and attempt to improve data visualization. Well, it's the data set is basically it identifies the skills which are in high demand based on their respective assigned ranks. The skills are ranked differently in every country, and some country prioritize a certain skill more or less as compared to other nations. The dataset also categorizes the skills on yearly basis and the period from 2014 to 2017 inclusively is used as a framework for analyzing the top skills. It has 4 columns: skill, country, year, and rank, and has over 800 rows of records. The most important objective to prove is the claim that statistical analysis, or data analytics, and cloud computing are becoming top ranked skills, and therefore their demand is increasing. Uh, all this data and the visualizations and the Jupyter notebooks provided in my GitHub account. This was the visualization that existed earlier. It shows you which LinkedIn skills are hard, and it clearly shows you that statistical analysis and data mining are in top demand. So I created a newer version or new visualization to support the same claim that the statistical analysis and data mining skills are in top demand. So this is what I created. My claim was top ranked skills are present in all the major economies as well as the emerging ones. So it's a box plot, and it shows you country-wise skills and ranks distribution. Uh, it shows you that the statistical skills, or the data science skills, or the data mining skills are in top demand uh, based on the whiskers of the box plot, covering from uh, the lowest rank to the highest possible rank. So, yeah. Here, my claim is that some technologies become popular simultaneously in all the countries, while other skills emerge from major economies and then spread across the globe. Here, you can see that in the 3 years from 2014, 2015, and 2016, the ranking um, is increasing year by year. Here, my claim is that increasing popularity in top skills is encouraging the previously less popular skills to become more demanding and rewarding. It's a bump chart, which is another very important chart type to show uh, the cause and effect in relationships. For example, since the data mining skills or the statistical skills are increasing in demand, it helps in other less popular skills to become more demanding and rewarding as well. For example, you can see Python skills, their ranking is also improving from 2014 to 2016 uh, as we are moving, as the statistical or the data mining skills are becoming uh, more in demand. All right. So this here my claim is that cloud and statistical data mining skills are consistently ranked higher among all the countries as shown by the positive skewness of their respective box plots. Uh, so you can see the top whisker of each box plot for the skills like uh, statistical analysis and data mining and cloud and distributed computing. It has positive skewness. So uh, that's what my claim is, and it's supported by this visualization. Deceptive visualization. The objective of this project is to create a data visualization that purposefully distorts the data or deceives the reader. Uh, you can start with an existing data visualization and develop a deceptive version of it. You will not alter the data and you will not change the data or show something which didn't never exist. Uh, However, you can incorporate external data and you can disprove the original claim by supporting another claim with the help of a new data. Let's see how it helps. So, but before that, let me show you what is deceptive visualization. So the purpose of this project is for you to experience and realize the ethical implications of design decisions during the development of data visualizations. For example, in this chart, what is happening is that is the y-axis is being truncated in the graphs, and because of that, there's a totally different message being proposed. A very common misleading data visualization example is changing the value of the y-axis starting point from 0 to any other number. And this blows up the differences when comparing data. For example, in the bottom left chart, what's happening is that the y-axis is not starting from 0. It's starting from 9100, and that's why you can see a sharp rising trend from categories A to E. However, y-axis on the bottom right chart is starting from 0, and there you don't see any rising trend. And that's how it should be. You should always start your y-axis with a 0 number. Otherwise, it's if you don't start with 0, it's considered as deceptive, especially if you show something, uh, some trend like this. In this case, a positive rising trend. So make sure you follow this principle. Another example of deceptive visualization: improper extraction or cherry picking. The graph below is a good misleading data visualization example. This graph shows the average global temperature from 1997 to 2012, and you can see that the goal of this graph is to prove that global warming is not happening by not looking at the previous data. And if you see the trend is very flat, there is no rising trend. if you plot from 1997 to 2012. However, the chart on the right shows the average temperatures from 1900 to 2020, and there you can see a clear increase in global temperature, suggesting that global warming is indeed happening. So, this is another example. For deceptive visualization, if we are using wrong chart type, uh, we should take into account your your stakeholder preferences, expertise levels, and communication styles, so that you do not use a wrong chart type. If you know your audience needs and their profile, their wants and their desires, what they want to see in the charts, and the expertise levels and communication styles, then you should always use the right chart type. Study the form and function of each chart type before using them, because before developing any visualization, we should also understand what each visualization is designed for. Only then we can use the right chart type. Ask yourself whether the chart or the graph serves a distinct purpose, and think about what message to convey. Now, this is very important. You have developed your visualization, but you don't have any claim, you don't have any story from it, then it's of no use. So, always make sure that you have some claim, uh, some warrant uh, that you want to propose through your visualization to your audience. So, for example, in this case, a pie chart is a poor choice as the visuals don't represent the numbers in their best or most accurate format. One on your bottom left, here you can see the pie chart is not the right chart type here, because pie chart is used when the categories are divided into percentages, and those percentages should add up to 100%. However, in this case, on the bottom left side, this is average transaction size by payment type. So the best chart type here is a bar chart. It's a horizontal bar chart. And similarly on the right side, uh, there are percentages uh, for the study amounts. So you can see that pie chart is best suitable on the bottom right chart and not the bar chart. So always make sure you know these things when designing any visualizations. All right, so in this project that I made for a deceptive visualization, I used this dataset called Australia Gender Pay Gap. Our main claim is that Australia's top 50 jobs pay men more than women from the original dataset that we used. And we analyzed the top paying jobs such as neurosurgery, ophthalmology, and internal medicine. They pay men more than women, even though women are competitively qualified and capable to perform equally well. So the dataset that I used is provided by Australian government for over 1,000 related occupations and their respective salaries for men and women in each occupation. The occupations are ranked from 1, neurosurgery being the highest paid profession, and 1104 being the lowest paid. The dataset has 5 columns: gender rank, which ranks every profession for man and woman, occupation name, gender, number of individuals in each profession, and average taxable income with the occupation and gender. This project is aimed at creating two contradictory visualizations, and I use Tableau to make them, using a selected dataset on a contentious and debatable topic. So this is a contentious and debatable topic that are paid more in Australia. However, I will show you later when I integrated and merged some external data, that claim was uh, not the right claim, because there's much more to it. Um, Initially, I developed a visualization that confirms our original claim that indeed men are paid more than women, and then by incorporating external data in the existing dataset using Python, I created a rebuttal visualization that would refute my original claim by providing a legitimate and valid arguments, claims, and warrants. So, even if you want to disprove some claim, you need to have it backed by real data. I mean, you cannot manipulate the data or change the data or make any false claims. Always make the right claims and always use the right data uh, to prove or disprove your another claims, and then show the audience what the real truth is. I provided this GitHub link where you can find all the material related to this project. Alright, so the one visualization I plotted for this project is a box plot. And here my claim is that male salaries in top professions in Australia are highly dispersed. As you can see, the box plot on the right side, it has positive skewness, and you can see there are lots of outliers on the top whisker, above the top whisker, and neurosurgery is way above that. So the median of the box plot for man is relatively higher than women, and they are skewed to the right and has positive skewness. And it's greater for woman box plot, indicating that most of the top occupations are paying man more than women in Australia. Um, Men are commanding around $550,000 versus women only $320,000 for a neurosurgery occupation. So here my original claim that indeed the salaries are highly dispersed and paying men more than women. All right. So here this this uh, this is another claim that I use, and this is a bullet chart. I designed it in Tableau uh, using this data. It's very useful for this kind of claim that I'm making here. Here I'm saying top ranked professions pay man more than women in Australia. So my claim is same. I just created several different types of visualizations to give my audience a flavor or the, the about the different visualizations available that you can use. You can build them in Tableau or Power BI, or you can design in Python using its libraries like Plotly. So here the visual shows that as the rank of occupation gets lower, the average taxable income variation between men and women gets narrow. So the top bar is for neurosurgery, and there you can see um, that the gap between it's a very long bar because neurosurgery it pays man more than females, and you can see that the gap between man and woman is much higher than for the lowest occupation, finance manager, financial controller, where the gap between them is very low. All right, so and this is DNA chart. This is another very popular chart that we can design in Tableau or in Python. Here my claim is again that Australia's top 50 jobs pay men significantly more than women. Uh, and the DNA chart, it's an accurate reflection of this claim. It represents the actual difference or spread between the two quantities, which are average taxable income of man and woman, represented by blue and yellow colors respectively. We can see that the biggest difference is in the top ranked profession of neurosurgery, ophthalmology, orthopedic surgery, and cardiology. The bigger the difference in the two quantities in the DNA chart, the more persuasive our claim that the top ranked jobs are paying man more than women. So you can see the longest line between male and female. Male is represented by orange and female by green. Is for neurosurgery, which means that profession has a lot of dispersion in salaries for men and women, and that supports our claim. So see, this should be the way to design any visualization, that it should have a claim. Every visualization should have some claim that you want to propose to your or show to your audience, and that's how these visualizations uh, make sense out of data, or they make data more understandable, and that's the topic of this course. Now, I incorporated external data from another website. Excuse me. And here my rebuttal means that disapprove the original claim by using some another data. So my rebuttal to the original claim is that full-time labor force participation of women is less than men in Australia. Now that's the fact. Since women are participating less in full-time uh, jobs in Australia, that's why men are paid more, especially in neurosurgery. So here it shows that full-time women participation is in labor force is 53% out of the total women population. Only 50%, 53% are working full-time. And out of the full labor force of males, 81.35% are working full-time. And that is the reason there's a dispersion in salaries, especially for top-ranked professions like neurosurgery and medicine-related occupations, where full-time availability is of utmost importance and of higher demand by the employer, considering the risks involved in the medicine and neurosurgery occupations. So that's why there was a dispersion, and not because of any other reason. So this is another visualization for the same claim that the full-time labor force participation of women is less than men in Australia. So this visualization, I took it from a source mentioned in the bottom of this slide, and it supports my claim. Here you can see the full-time participation in Australia for ladies is 61.7%. However, for males, it's 86%. Alright, my next project is investing in cryptocurrencies. So my target audience here is a potential investor interested in diversifying portfolio of investments, and in order to maximize expected return and minimize foreseeable risk, the ultimate objective is to invest in an industry different than the existing ones, and we are analyzing positive and negative aspects of investing in cryptocurrencies, especially Bitcoin. So my audience need is that they are interested in taking profits by using the arbitrage opportunity embedded in cryptocurrencies, which means buy low and then sell high. And we can see the patterns and trends of cryptocurrencies historical prices. There are short-term spikes and upticks in the prices, which has profit-making opportunity for prospective investors, and that's when those investors jump in to buy those assets at the right time. What my audience want is that audience for this analysis of Bitcoin investment is a prospective investor intending to diversify investments. They already have made some other investments, and by investing in cryptocurrencies, they want to uh, diversify their investments so that if other investments go down, this may increase, and vice versa. So, what are the audience fears in this case? Audience fears are because cryptocurrencies are not backed by any government or a regulatory agency, and they do not have any centralized authority to secure them, and the operations are decentralized as compared to traditional centralized banking system and financial market. So audience fears would be safety, reliability, and enforceability of the investment in cryptocurrencies. So there on the bottom part of this slide is a GitHub link to this project where you'll find all the material relevant to it. Alright, so for this project I use some spatial charts, and the first one is a candlestick chart. What is a candlestick chart? It's a chart used mostly in stock market data or for financial data, and it's used to describe price movements of a security, derivative, or currency. While similar in appearance to a bar chart, each candlestick represents four important pieces of information for that day: open and close in the thick body, and high and low in the candle wick. Being densely packed with information, it tends to represent trading patterns over short periods of time, often a few days or a few trading sessions. They're also used for IoT sensor data or time series data, and I use them in my current uh, work as a data scientist as well. So you can see on the top right chart, it shows you the black candle and a clear candle. So the it shows that the bottom part of the whisker is a low price and the top part is a high price, and the bottom part of the box or rectangle is a close price and the top is open price. So the components are, it shows you open, high, low, and close prices for each trading day in stock market. And Candlestick has a wide part called the real body. This body represents price range between the open and close of that day's trading. When the real body is filled in or black, also red, it means close was lower than the open. That's why it's red. And if the real body is white or it's green, it means the closing price was higher than the opening price, and that's why it's green. All right, this shows you some visualizations where I compared Bitcoin versus Ethereum, which is another cryptocurrency. And my claim here is that Bitcoin is less volatile than Ethereum. Why? Because you can see the top chart is a Bitcoin's candlestick chart, which shows you a sharp rising trend from the beginning and towards the end. This data set used data from 2013 to 2017. So all the way from 2013 to 2017, Bitcoin showed you um, less volatility and and a sharp rising trend, which means that uh, you can, if you plot a line out of it, you show it's increasing rapidly. However, Ethereum was more volatile, which means that it had ups and downs, especially during the year 2017. That's why we can say that although it increased, but it did not increase as consistently as Bitcoin. So that's why my claim is that Ethereum is more volatile than Bitcoin. So another popular chart type that I use in this project is a Bollinger Band. And Bollinger Band is a popular tool among investors and traders in stock market and financial markets. They help gauge the volatility of stocks and other securities to determine if they are over or undervalued. It's a technical analysis tool used to determine where prices are high and low. These bands are composed of three lines: simple moving average, the middle band, and an upper and lower band. The upper and lower bands are typically two standard deviations above or below a 20 period simple moving average, or SMA. The bands, the upper and lower bands, they um they widen and narrow based on the volatility of the underlying asset changes. So as the upper and lower band uh, widen apart from the middle line, which is the moving average, that indicates higher volatility. And if they come closer to the more simple moving average, the upper and lower band, that indicates lower volatility. And it's very useful for stock market investors to identify um, the future price changes that are expected. So that it's used a lot in technical analysis, and investors identify the right time periods for investment, for buying or for selling. So if we compare Bollinger Bands to compare volatility, we can see that Bitcoin Bollinger Bands, which is on the top left, had the top and the lower bands, upper and the lower bands, they were very close to the simple moving average, which is the blue line, which means that the volatility for Bollinger Band was much less. However, it kept increasing sharply. However, for Ethereum and for Litecoin on the right side, you can see that the the upper and the lower band, they were wider, much wider than Bitcoin from the simple moving average, which indicates that they had higher volatility than Bitcoin's Bollinger Band, and that suggests that Bitcoin was definitely a very good investment for investors all the way from 2013 to 2017, the time period of this data set. All right, so here I'm just comparing the different data visualization libraries available in Python. Python provides lots of very powerful data visualization libraries that we can use to build very cool and very colorful and very meaningful visualizations that appeal to audiences, and they have very wide variety of colors, the hues and intensities of colors, and lots of different customization options in each libraries, meaning you can customize your charts in lots of hundreds of different ways, like hovering and the legends, or integrating multiple variables on the same chart, and making your chart basically more and more customizable and user friendly for your audience. So the libraries that I define here, they come with different features, and they can support lots of different types of graphs. So the matplotlib, it's an easy to use low level data visualization library. It's built on NumPy arrays. It consists of various plots like scatter plot, line plot, histogram, and it provides a lot of flexibility. Seaborn. Seaborn is a high level interface built on top of Matplotlib. It provides beautiful design styles and color palettes to make more attractive graphs. Bokeh is famous for its interactive charts visualizations. Bokeh renders its plots using HTML and JavaScript that uses modern web browsers for presenting elegant, concise construction of novel graphs with high-level interactivity. And Plotly, I would say the most powerful among all and more versatile library. It has hover tool capabilities, for example, that allow to detect any outliers or anomalies in your dataset. It allows much more customization than any other packages in Python, and it makes the graph visually more attractive. So here I'm showing one of the very popular web analytics tool that Plotly in Python provides. It's called Dash. Dash is Python framework for building web applications. It's built on top of Flask, Plotly.js, React, and React.js. It enables you to build dashboards using pure Python. Dash is open source and its apps run on web browser, meaning you can put those apps on web browser. Anybody anywhere can access them with your obviously with the credentials, and they can use those charts for their own data analysis. Um, and this is one way that supports the modern BI versus the traditional BI, where only the IT staff can access those platforms. But now everybody in your organization can access them and use them for data analysis in their own way. So a Dash application is composed of two parts. The first part is the layout, and it describes how the app will look like, and the second part describes the interactivity of the application. Dash provides HTML classes that enable us to generate HTML content with Python. It's the most downloaded, trusted Python framework for building ML and data science web applications. So here on the bottom left side, it's an interactive visualization. You can just use a pull down menu, um, select the name of the company, and it will show you the stock price from 2017 to 2012. Oh no, 2021. And on the bottom right, it's a dashboard, interactive dashboard running on web, which shows you life expectancy at birth, among other categories that you can use, and the charts will be updated based on your selection. So that's how they work. You select some input, and the charts get updated automatically based on users' input. It provides a lot of flexibility. Here I am providing two another examples of Dash applications. On the bottom, on the left side, it's a Walmart store openings in US uh, that you can use to find where how many stores open in a certain time period in US uh, according to the states you select. On the right side, it's a PDF app, and if you click on something, it takes you to that part of the report and provides user to much more um, friendly and faster way to browse through the PDF report. So Dash is an open source app, almost 350,000 downloads monthly. Uh, so one difference between Dash and Tableau and Power BI is that Dash is free. It's totally customizable. You just need to know Python and some HTML, and you can design it in your own way. Make lots of customizations, and it's free. Tableau is expensive, but Dash is free, and you can use it for organization-wide data analysis. This is another app of Dash. It's called New York Uber Rides. So if you select some time period and if you select some the location in New York City, for example Times Square, then and certain time period, then it will show you total number of rides, Uber rides that occurred at that time at that location. It's basically a spatio-temporal data analysis using space, the location, and time about the data that you're looking at here. Dash is most downloaded trusted framework for building machine learning web applications in Python. For example, if you have built some ML model and you want to analyze the results of it, how accurate or how good it is, you can use Dash. So here, if you select some dataset um, and some kernel, then it will show you the ROC and the confusion metrics and other benchmark metrics to basically evaluate how good your model is. Data visualization tools available are Tableau, Qlik View, Power BI, Google Charts, and D3.js. They have pros and cons. Pros could be ease of use, versatility, their power, and cons are cost, learning curve, and limited customization. Um, all of them are paid. Most of them are paid, like Tableau. Um, so Tableau is easy to use. It supports a wide variety of data sources. It can create wide variety of charts and graphs. However, it is expensive. Power BI, powerful, versatile, can be used to create a wide variety of visualizations. But for Power BI, you need to have a Windows machine, and it's good for larger complex data sets. It can lead to performance bottlenecks, however. Alright, so what are some of the trends in data visualization? We discussed so much, but the trends are that it enables you to provide storytelling with data. It has AI powered insights. It has real time visualization. It has wireframes, data democratization, explanatory visualization, mobile friendly visualization, and so on and so forth. These are some latest trends that is powering data visualization as it is so much useful for data. It was and it will be um basically to make our data more understandable. Alright, so what is the conclusion of this course is that data visualization has emerged as an indispensable tool for transforming raw data into meaningful and insightful representations. As the volume and complexity of data continue to grow exponentially, effective data visualization techniques have become essential for extracting knowledge, identifying patterns, and communicating insights to a wider audience. Now I will provide a demo in Jupyter Notebook where I will show you data wrangling in Python that I did before for the three data sets or for the projects that I described, and I will also show some Plotly demo. Alright, so here I am for in the LinkedIn using that LinkedIn top skills data set. As I discussed, the exercise is was to I took this data set from a website called Makeover Monday. The data set has 4 columns: country, skill, year, and rank. Excuse me. It shows which skills have been in demand using respective ranks and countries, where the skills are used or becoming popular or decreasing in popularity. It will show you. So a crucial takeaway of the dataset is that data skills are becoming more popular and increasing in demand in all the major countries. And ultimate claim is that statistical skills, data mining, and cloud computing are becoming top-ranked LinkedIn skills, and therefore the demand is increasing. So here I imported all the packages required for this data wrangling. I downloaded and saved the data set on my machine, and then read it like this using pandas. Here I'm analyzing the first and last 10 rows of the data. Now I'm plotting or making some descriptive statistics of the data using central tendency and dispersion. So it shows that there are 70 unique skills, and the top skill is statistical analysis and data mining, which satisfies our main claim. It also shows that there are 15 countries in the data set, but the top country used is global. Also, 75% values of a year column has 2015 as the year. So now I just analyze it here. I'm just grouping by rank to describe, and it showed that the top ranks from 1 to 10 are mostly distributed with 75% in 2016, and from 1 to 10 they have counts of over 41, indicating the high demand of top 10 ranked skills, which include data analysis, cloud visualization, and database management. Here I analyze the data types of my columns. Here I got the countries out of the dataset. Here I found the unique skills used in the dataset. Then I found out the years used. I analyzed which skills are used most often. So you can see data analysis and statistical skills, they have the biggest count. Then I said which countries are used most frequently. Well, you can see France, global, US, Australia. Now I plotted the box plot to analyze relationship and distribution between rank and year entities. You can read it when you browse through this notebook. Here country using here I analyze country counts using bar charts. This is the chart that I draw in using Python. And it shows that the count skills indicates the number of times respective skills is mentioned in LinkedIn top skills. Advantage of this chart is to quickly analyze frequency of each skill in consideration. Higher the frequency and occurrence of the skill, higher the popularity and demand of that skill. And the biggest skill count is for statistical analysis and data mining, around 41, which supports our claim that data skills are increasing in demand and popularity. Alright, so this was the LinkedIn top skills dataset. Then I use this data wrangling notebook is for the Australian gender pay gap project that I discussed, where my original claim was that men are paid more than women. However, our final objective in this project is to contradict our original claim that men are paid significantly more than women by using some external data. Here I imported the libraries, saved the data locally, and then read it using pandas. Here I analyzed the last, first and last 10 rows. I dropped the unnamed and empty columns, removing nulls. Then I analyzed descriptive stats, checked the data types, reviewed the column names, and again checked for any missing or null values. They were zero. Here I renamed some of the columns in the dataset. Okay, so I converted the number of individual to an integer data type and gender and occupation to a string data type because they had no data type or object data type initially. So this data set was not very clean, so I had to remove some white spaces and special characters from occupation and gender columns using this code. Here's some visual analysis for male and female. It's the same type of. It shows the same uh, idea that I got from when I plotted in Tableau that I showed you in the slide. That male salaries are highly dispersed than female. Here I plotted some box plots. Oh, sorry, some line charts using matplotlib. So the idea behind this is you do data wrangling before creating any visualization, where you clean data, you do your statistical analysis, you plot some charts out of it, just to have an idea how your data looks like, and to prepare the data for further usage where you build visualizations. For the rebuttal of the original claim, I use two data sets here, and then I use the data that was needed for my task. Then I merged it with the original data set, filled out some missing and null values, and that's how I prepared the data and saved it to a file which I used later in Tableau to build my visualizations. Alright, and the last notebook that I want to show you is for Plotly Dash. So here I use uh, Dash and Plotly to give you a demo. I'm preparing a small Dash app here in Notebook using data from this link. It's a country-wise population chart. So here the idea is that you use this pull down menu and make your selection, and the chart gets updated dynamically based on your user input. That's that's how Dash works. Then I plotted some pie charts for the demo. It shows you population of European continent country-wise. So here you can see. So the idea of pie chart is that all of these percentages should add up to 100%, and only then you can use right type of pie chart. And it shows you very easily which country has what proportion or what percentage of population in the whole European continent. So if you hover over it, you can also find the country, because otherwise it will be difficult to mix and to match with the color. So if I hover over this 14.1%, this shows this is Germany, and apparently Germany has the highest population in Europe. Population of American continent, US has the biggest population in American continent. And here I developed some bubble charts. So you can check out this code in this notebook which I used, and after I plotted this is how it looks. And it's a bubble chart where each bubble represents life expectancy versus per capita GDP. Um, So yeah, as you move from left to right, the GDP per capita increases. So America has one of the highest GDP per and life expectancy. So the size of each bubble is also has also some meaning out of it. Here I developed box plots. Yeah. Box plots show you statistical distribution, how your distribution looks like, if there are any outliers. So here I show you points scored by some top 9 scoring NBA players in 2012. And you can see this guy, Damian Lillard, he had the highest distribution, that he scored some very low and some very high as well. While David West is quite consistent. Then I plotted some contour plots. Their contour plots are very useful. They use some color scheme. They're also called gradient plots, or you can say heat maps. So based on some color, they show you some pattern out of it. So this is how it looks like. Then I plotted some candlestick charts using the data here, financial data for Apple stock price. And as I discussed earlier, the green candle is when the closing price were higher than the opening price, and the reds are when the closing prices are lower than the opening price. So this shows you some volatility in stock price movements. Then I plotted a very common chart called a line chart using the data for average high and low temperatures in New York for different years. So see how different lines show you different ways of representing the data. Then I plotted bar charts for population of Canada from 1950 to 2000, 2000. It shows you definitely a rising trend out of it. This is US export of plastic scrap um, data. And then in the end, I showed you we can also build animations in Python, meaning if you click play, your chart will run, showing you trend from the beginning of the data to the end of data. So this is again the GDP per capita and life expectancy. And if you play from 1952, this is how it looks like increasingly, some increasing pattern, sharp rising trend from 1952 and from 2007. Alright, so this was it, and this wraps up our course for data visualization and business intelligence. Hope you enjoyed this course, and I hope this is useful for lots of students in their endeavors, in their data science tasks. And do subscribe to my channel if you want to stay tuned and you want to be notified about my next videos. So thanks, and God bless you all.